all for attending today. Drones have become such an important tool across the New Zealand drone industry. They're being already used across, emergency services, agriculture, and critical infrastructure inspections as well. But as we move forward, so many of these organisations are looking to what's next. How do we start to streamline these operations and see those cost savings that, they've been promised over the years as well. So hopefully today, you'll get a really great, what we think is next, or what is actually here now, but what is going to be those important steps in the drone industry to lead the industry to those next stages of, more automation, flying multiple drones at one time and seeing those cost savings. I'm just going to take a stream. So over the next hour, we're going to introduce you to a great New Zealand and the leaders of different components for the New Zealand infrastructure. So we have the team from Ferntech and also from Orion as well that will be joining on this webinar and sharing their insights. Feel free to reach out to any of us after this session. As we move through the slides, you'll see sort of a barcode near each presenter that's linked to their LinkedIn, and also there's also a barcode linked to each specific company. So feel free to reach out if you've got any questions. Over the next hour, we're going to, first we're going to hand over to Ferntech, and they're going to sort of talk about their remote operations center. You're going to get an insight to what one really looks like. They're also going to do a live flight, so, bear with them. Doing anything live, especially a live flight, can be sort of, I guess, a little bit nerve-wracking. So let's bear with them, and we look forward to seeing that. From there, we're going to move and look at a real case study with Peter from Orion, and then we're going to find out, how do we actually make this work? It's great, and we can see the use cases, but, how do we make it work within the current regulatory framework for New Zealand? So Nick from my team at Hover will provide that information, and then we're going to flick back to the team at Ferntech that we'll look at the hardware and what's required to, start or do a trial or a testing as well. And then at the end, we're going to have some time for Q&A. And if we don't get to answer all your Q&A, we will reach out to you separately to sort of provide that information. So today, please, there's a Q&A button. Please type as we go into those sessions, and we'll keep an eye on that as well. So a quick introduction on who we are. So Hover's been around for nearly 10 years. We have an office based in here in New Zealand and also in Australia, and we just love helping people move forward with their drone programs and to get the most out of what they need. So we work through trials and testing, through to providing all the support and information and documentation they require for operational approvals, such as beyond visual line of sight and some of the things you'll see here today, through to everyday compliance as well. So we help people sort of manage as their drone program grows. Quick introduction to myself, because I didn't do that, but my name is Jackie Doomovich, and so I am the CEO and founder of Hover UAV. Please, I love talking drones, and usually I don't sort of shut up, so I'm always available. Please reach out. It doesn't matter what stage of your drone program. If you're just watching it now going, we know drones aren't going away, we know we've got to incorporate it, but we don't know where to start, feel free to reach out to me, and I'm more than happy to sort of walk you through that process as well. You know what, let's get started. We're here to see these live flights and to hear more about, what's actually happening already in New Zealand. We're ready for these remote operations. So we'll hand over to Ferntech. So, Ferntech have been around since, it's 2013, so been around for a long time, and are one of the major and critical support organisations in New Zealand, with providing a lot of the hardware and advice and different software solutions to the end users across New Zealand. So with I'm going to hand across to Cody in a minute. I do have a quick bio on the video, on the PowerPoint. I'm not going to run through their full video, so I'm going to allow each speaker as we move along to sort of introduce themselves and give a little bit of an insight to, I guess, what they do within their organisation and what their organisation does. So first I'm going to pass over to Cody and a video from him.
Cheers, Jackie. Hello, everyone. My name is Cody. Thanks for joining us today, and welcome to our Remote Operations Centre. I have been the primary dock pilot for over a year now, performing over 200 flights. This is the first Remote Operations Centre to be approved in the country, and we have been working closely with Orion to make this happen. The dock is currently located on an Orion substation located in Norwood, Christchurch, and that's where we've been doing our trials over the past year. Peter from Orion will also be talking later in the webinar about the project. In the last year, we've been operating under extended visual line of sight, so we've had someone on the substation with a standard remote RC for the drone, so if anything were to happen, they can take over and fly manually. Now, with our BVLOS approval, we can fly remotely from the RSC with no one else on site.
Cool. So now we're in Flight Hub here, Flight Hub 2. So Flight Hub 2 is a cloud-based software where we plan our missions and deploy all the flights for the dock. We can also, with its cloud storage, we manage all the data being captured from the drone. On the right-hand side there, we're looking at the live camera from the dock. As I said, it's based down in Christchurch. It's a great day down there today. So we're all good to fly. I think the worst part about having the ROC up in Auckland is when it's a crappy day up here and it's looking like that down in Christchurch, and you're sort of stuck in the office, stuck in the rock. What we'll do is we'll jump into an automated mission here straight away, into an inspection mission we've got set up. So we'll come into our task plan library and create a plan here. First thing we do is call this mission a name. We'll select the flight route that we want to do. So today we're doing the SF6 full inspection. So if we look around here, we can see the flight path. There's about 27 different waypoints, 6 or 7 odd gauges. So these gauges are telling us if there's any leaks with the sulfur hexafluoride. Basically, there's a little arrow shown whether it's green or red. If it's in the red, we know there's a leak and it can be managed. So we'll select our device now. We're going to select the dock as our device. From there, we'll select an immediate flight today, but if we wanted to, we could do a timed, reoccurring, or a continuous mission. So if we wanted to fly once a week, once a month, you've got the freedom to set that up to however you need. We'll set our return to home altitude, 30 meters for this mission here. We're not flying very high. If signal lost, it returns to home. Upon completion, also return to home. Now we'll click OK. As soon as we've clicked OK, that's going to start uploading all that data to the dock and the drone. Once that loads, we'll go back and we can look at the live camera and we'll be able to see the dock opening. It's also going to trigger the drone to power on and start connecting to GPS and getting set up. So dock's just open there. Drone should be powered on shortly. Now we can see the drone's powered on, so we can switch between the M30 camera and the FPV camera on the drone. So that's looking at the wide camera on the M30. If we wanted to, we can click on payload control here and switch between the zoom and the IR camera as well. For this particular mission, we'll be predominantly using the zoom camera because we want to zoom right into those gauges to be able to see them clearly. So what it's going to do is at each waypoint we can see we've got down really low. So we're going to use the zoom camera, zoom in, it's going to take a photo. As soon as the drone lands, all those photos will be uploaded directly to Flight Hub 2 on the cloud. So then we can look at them after the mission. So drone's taken off now, the dock closes up while it's doing the mission. And we can see an arrow on our screen here, if we zoom in, we can see the drone following the flight path. This first waypoint here, there's actually some lines. It flies down and comes underneath the lines. You might be able to see the lines as it's coming down on the wide camera. As it will rotate here. Just above us there's some lines, so it's going to come in underneath. We'll switch over to the zoom camera. It zooms in, it's going to take a photo of that gauge and then head back out and continue the mission. So it's really quick. So we don't actually need, during the live flight, we don't need to see the gauge during the flight. It's obviously taking that photo so we can inspect that later. Continue on here. Having the 3D model, we can see on the main screen there, we can precisely plan the mission so we know exactly where the drone's going to be. So we can get super close to the assets and knowing that we're not going to get into any trouble. If we did plan it too close, the sensors kick in and the drone will return back to the dock. So during testing, if that happened, we knew just to adjust that waypoint a little bit, and then we're good to carry on. So here's another one here. This mission also, it looks awesome on site. I mean, it's cool looking through here, but watching the drone fly around at the speed it is and taking these photos on site, it's pretty impressive. All the photos it's taken as well, it's building that database and it's using AI to actually teach the drone where the gauges are. So it's using what's in the image to teach itself, so we know we're going to get the same photo every single time. So you can see it actually does a little adjustment. It zooms in, lines it up, it does a small adjustment to center the gauge, and that's the AI kicking in to make sure we get that same image every time and super repetitive. So we can see there on the wide camera how far away we actually are and how far it is actually zooming in. If we look at the thermal camera now, it's just like if you've ever flown a thermal drone before, DJI, you can look at your different isotherms and pellets, I should say, and then we can also go side by side. We pull up the different pellets here, we can switch through them. We can look at the side by side. Currently the right-hand screen is the zoom camera. If we wanted to, down the bottom right, we can zoom out so we can have the wide camera and the thermal camera side by side. If we wanted to, we could pause the mission and take over flight manually, actually flying the drone from the keyboard on the computer itself. So it's almost wrapped up here. This mission only takes about 3.5, 4 minutes. So that time there to inspect all those gauges, the substation's about a 40-minute drive from Orion's headquarters. So the time saved on getting someone to drive out there and have a look is massive. Now we're back over top of the dock. The camera's facing down. It's going to start its landing, and the dock's going to open up, ready for landing. And then once the drone's landed, the dock's closed up, all that data, all those images we just captured, we'll start uploading to the cloud, and then we can go and have a look at them. So I'll do a little pause here. I think there's a bit of a breeze down there today, but it's no issue. And we can see it's landed there back in the dock. It'll reposition itself so it's centered, and then dock will close up. So if we jump into Flight Hub now. Cool. So here, this is the site down in Norwood. You can see there's a pretty big stretch here. So there's actually power lines coming from the substation all the way up Highfield Road, up to the Highfield substation. What we've done here, this green sort of train track looking boundary, this is our geofence. So the drone can't actually fly outside this geofence. With the 3D model currently, we've got a mesh loaded in. We can also load in point clouds as well. So we've modeled this area and the whole line down the road with the L2. So I can turn off the mesh on the site. It'll go back to just Google Maps. And obviously, if we're trying to plan that mission we just did, there's no way we'd be able to do it looking at that. So that mesh is sort of essential. If I load the point cloud, we can see data down this whole line now. Obviously, the LiDAR is going to pick up these power lines a lot better than photogrammetry, so that's why we use that one in this instance. It's about a 5 kilometre stretch down to the Highfield substation, and we did manage to do a flight down here from the dock using the 4G transmission. I'll switch back to the mesh. We'll come over here and we'll look at the different flight routes we've created. Other ones we've created on site is a perimeter sweep. So basically just going around, checking the gates are closed, checking the fences, there's no holes or anything, there's no one being trying to get in there. And also a bunch of other different inspections, checking the connectors, isolators on site, and etc. There's so much potential. We've got thermal maps. So this one here is just a standard mapping mission using the thermal camera over the whole site. If I jump into edit on that mission that we just did, I can see all the waypoints here on the left-hand side, so 29 waypoints. And these ones here with the little camera icon, these are the waypoints where we've taken a photo of the gauges. So if I click on the first one here, that's this one down here, shows us where the camera's looking. We've added annotations as well, so we can pick out clearly where those gauges are. There'll be a photo loading up here. Let's try this one here. Try this one. So the image is obviously still uploading. Here we go. Cool. So now we can see this blue box is the image we're taking every time. With the AI spot check, we can move this around, change the position of the photo, but we know with this AI spot check turned on, it's going to take this exact photo every single time. If I come back out of here, open up our media files, come back to all files here. So demo, this one here today, I'll load this up. And it's taken a photo of the wide, using the wide camera, the zoom camera, and the thermal together. So we can see here on the wide camera how far away the drone actually is. The gauges in here, obviously, we can't see the status of the gauge from the wide camera, but when we look at the image from the zoom, we can easily see the needle is on the green, and we're all clear there, no leaks, and takes an IR photo. But in this case, the IR imagery for this mission isn't too useful. Awesome. So that's a bit of a rundown there on Flight Hub and how we run the missions, how we set them up. I'll hand over to Peter now, who'll be able to talk more about this project. Peter, over to you.
Thanks, Cody. My name's Peter Allen. I'm the Network Access Manager here at Orion. We'll quickly show a quick little video.
We're here today with my colleagues from Orion, Kinetics and Ferntech trialling drone technology to do automated and eventually pilotless inspections of this site. It's all part of the innovation Orion showing as we look ahead to an electrified Aotearoa, and also one we need to lean into the challenge of resilience.
It uses smart technology, so when it flies, we actually tell it to fly to a known location, a waypoint, and those could be multiple, so we can navigate our way around objects so we don't put the drone or our network at risk. We can live stream that back to our control room, and that will allow us to actually see a status real time, which will save us a huge amount of time later.
Technology like this will really help us do what is core to Orion, which is safe, resilient, reliable networks, enabling us to find faults, really difficult to find faults earlier and fix them before they cause outages, and send the operator to the location as opposed to them having to find the location. So all around, it's a great win-win.
Traditionally, you would need someone to go out to site to have an actual visual check. Now, having the drone being able to be remotely operated, someone can be sitting in the office and confirm whether the switch is physically open or closed.
So technology like this, which enables us to be at the leading edge in terms of fault finding, preventing faults, restoring faults, is absolutely where we need to be.
Yeah, so talking again, my name's Peter Allen from Orion. As I said, Network Access Manager. Orion is a utility provider for the power in the Canterbury region, South Island in New Zealand. Our job is to distribute the power in our region. We've got about 225,000 customers. We take it from the grid provider Transpower, who transmit the power up and down the country. We take that energy from grid X points, which Norwood is in fact one of them, and distribute them all the way to a customer's house, and the customer can use them. As you see, our area is between the Waimak River and the Rakaga River, and stretches from the tip of the Banks Peninsula all the way through to the main divide and Arthur's Pass. Orion's been using UAVs for a number of years. We started about 4 years ago, and we started by giving UAVs to our field staff, training them to use them to get high quality, high resolution images of faults in the field. Keeps them out of danger by allowing them to use the UAV to go to places where they can't while they're in visual line of sight, and get really high quality data we can give back to our contractors to get works completed. As technology actually moved forward, UAVs are able to actually start putting things like thermal cameras into those UAVs, and we were able to take advantage of that. Really difficult faults to find normally with just the naked eye. The fault you're actually looking at here is a sensitive earth fault. That is really difficult to see. The insulator on the top here is actually looks okay visually, but in fact has a crack in it and has caused a fault. The latent heats you can actually see in the cross arm and the main pole is actually what denotes there's a fault there, and that latent heat can stay for quite some time. We also use UAVs or the flight hub feature to do pole top inspection and be able to use that for contractors and other members of staff to actually see what we've done in the field. And Flight Hub 2 is really fantastic for doing things like looking down on top of poles and seeing things that are very difficult to see from above. We had an EEA conference, or electrical engineering conference, about 1.5 years ago, where the Doc 2 was being released, Doc 1, sorry, was being released, and Ferntech, which we already had a partnership with and had been working with for some time, had actually told us that they intended to bring a Doc 1 into the country, and wondering whether we would like to trial it on one of our sites. We jumped at the idea. We've been using UAVs for some time, as I said, and we thought this would have a logical step in for our substations. So we quickly actually signed a memorandum of understanding with Ferntech, so we understood what each other's responsibilities were. And what actually happened at the same time was in that MOU, we decided what we're actually going to look at for using the DOC, which was to have site safety operation, whether it will just operate in manual flight, how autonomous flights would work, what the imagery would look like that we'd get of our equipment. Could we live stream that imagery, and then what would it look like for the on-site equipment? And then what would the repeatability of those missions look like? Could we get the same imagery all the time? How would that happen? We were really lucky at this time that we had our Norwood Zone substation being built from scratch. It was a greenfield development. It was a really important part of our network going in to strengthen our rural area of Canterbury. It was also a combined grid exit point with Transpower. Why it was so advantageous is that this site was actually de-energised through a period of the obviously construction until it was ready to go. We were able to quickly get the dock onto that site, map it, and start using the UAV in and around that site in a pretty risk-free environment. We could wait until the contractors left. We could get up, fly the UAV around our equipment to feel that we could be comfortable with the equipment flying progressively closer to our equipment without issues or fault. And we were able to complete a number of missions before the site was eventually livened. As the site was livened, we actually pushed the UAV closer and closer to see whether we were going to get any issues with RF interference or they were going to cause problems with the UAV. And realistically, the only problems we had during the process was with a few programming areas, which we were just learning what we're doing. And with Norwood being quite a remote site, it's about 45 minutes from our office. It's not manned, obviously, none of our substations are. We wanted to be able to protect it, secure it, and we wanted to know whether a UAV and a dock would actually perform that function. While we're actually under construction, we had Ferntech come down. They helped us provide a lot of the technical support to actually help us with getting the UAV in. We were pretty good at flying, but the dock was obviously new for both of us, and it was put on a trailer so we could move it around if need be. It's actually exactly where it still is today. So realistically, what did we get out of the dock? Oh, the dock met all of our expectations, and in fact exceeded them. We started off with 5 basic missions. We very quickly learned that those missions could do a lot more, and moving through to a really complex mission that Cody showed there with the EC6 gauge inspection, sulfur hexafluoride. It's really important. It's a greenhouse gas. We need to make sure we monitor it, keep it safe. Not only that, Cody touched on it there, but for the aircraft to be able to take off from Norwood, fly to our Highfield Zone substation, which is about 5.5 kilometres away, inspect that substation, and then fly back and still have about, I think they had about 38% battery life when it came back, was actually extremely impressive. And when I talk in a minute about some of the future possibilities of this equipment, it really did. That really gives us some, really did exceed our expectations. What did we learn? Communications is always key, not only actual communications on site, which is important, things like we're going to be throwing hard fiber links into that site. We have used Starlink and mobile cell on site for comms at the moment, but it's also communications between the subject matter experts at Ferntech and us as subject matter experts on site, and there's lots of learnings to do there. It's not to be terms we use, they don't understand, terms they use, we don't understand, and it took a little bit of learning. But it really helped Orion realise the potential of using these UAVs to do things like, say, get productivity gains, better data, and it improves our safety for our staff, network, and public safety. For us, what does the future look like? And I think this is probably what a lot of people will be asking today is, the utility around the dock being in the substation is really great, but we want to move forward in the future and actually do the work with Ferntech and civil aviation authorities to get these approvals done. But we're looking at either inspecting other sites like Norwood, the drone dock at Norwood being able to inspect Highfield, and then also looking at pole top inspection where we can actually look at our assets in the field. That's really critically important for us. I think as time goes on, we'll be able to teach an AI to look at fault identification, but just inspection on the top of the pole that a human being can look at gives us a perspective we don't normally have, and have the dock to be able to autonomously do this or do it through a pilot would be fantastic. Oh, there's one missing there. Here we go. And what we're actually doing at the moment is trialing AI for asset inspection. So we're going through a big asset management update at the moment with new systems, and we need to know what is actually on our poles. And the AI inspection for those poles is making a big difference. So we would see the dock playing a pivotal part in that going forward.
Cool. Thank you very much, Peter. Fantastic sharing your insights. Peter is a real technology champion at Orion, and he's leading real change in the electricity sector, bringing real efficiencies. So hello all, thanks for joining. Yeah, this is the first webinar we've done in a couple of years, so thanks to Hover and Orion for making it happen. And before, that live demonstration was fantastic. Thanks to Luke, who was piloting from our remote operations center in Auckland, and Cody, who was narrating over the screen. So yeah, here at Ferntech, we're very excited, myself and the team, to bring this technology to New Zealand and help customers unlock the real efficiencies that this technology has. So over the last decade, we haven't seen a change in drone technology quite as big as this drone in a box. The last big change was the introduction of onboard RTK, which really revolutionized the survey industry with precise georeference imaging, which delivered amazing workflow and efficiency to the surveying industry. And now with the drone in the box, we're seeing this new wave of innovation and efficiencies coming to the industry. So just to summarize, Ferntech, we're based in Christchurch and Auckland, and our overarching goal is to support our customers with the adoption of drone technology. And we do this by gaining a real in-depth understanding of the products we supply, using them daily with demonstrations, service maintenance we perform on them, and proof of concept with customers. So the launch of the Dock 2 and the DJI Dock, the only way we could see ourselves learning and gaining the knowledge we needed to help the industry was to go through the path of getting the first BVLOS ROC approval in the country. So Orion was an ideal customer to help us with this. As you saw from Peter's talk, we're obviously flying the drone around some very expensive, sensitive infrastructure, and over 200 flights that we performed over the last year, didn't miss a beat. It just really proved the reliability of the software, which really gave CA the approval to help with that regulation. And obviously Hover are experts in the regulatory field, so they helped us a lot there, just get all our paperwork across the line. So why is a drone in the box technology a game changer? So it's not going to work for every situation. Like Cody alluded to before, being stuck in the rock, not outside, there's still going to be lots of times when a portable drone is going to be the best solution, the most efficient one. But we see the drone in the box paying real benefits when we have remote sites where time to site is expensive, time consuming, and when there are repeatable missions that just can be done automatically. So first of all, the huge benefit is no human on site. And you look at the New Zealand road toll, it's a terrible stat that not a good thing for our country. So just huge increases in safety, not having your team on the road driving to these remote sites, and also the reduction in carbon in the air, where a lot of industries focus on a net carbon zero future. So remote dock drone sites will really help with this transition as well. Secondly, pre-programmed missions with automatic takeoff and landing reduces staff training to be drone pilots, and it enables specialist personnel to dedicate their time to analyzing data and generating actionable insights rather than collecting the data. Thirdly, automatic data management. No more stresses about forgetting SD cards, downloading, re-uploading the images, sharing with your customers and clients. So that's just all automated, as Cody showed before. Once you land the drone into the dock, automatically uploads to the cloud. As well, automated battery management. As soon as the drone lands in the dock, it's automatically recharging for the next flight. And also the dock is keeping it in a nice weatherproof box. So, a lot of hassles that you don't have to worry about. It's all automated. And as Cody showed before, a lot of amazing routine missions you can set up. So in New Zealand, We see various industries that will be transformed. With the examples we've shown so far is 3D asset inspection on a substation. So that's just one example of what we've seen. We've also seen it being a huge potential in solar farms, having the dock on site pre-construction, so you can do regular maps or mosaics to track the construction progress, and upload that into your software and just make sure that your construction's on track. And then once the solar farm's built, you can use the drone to inspect the solar panels, thermal imaging on the top to find for faults, and also missions lower down to check that the infrastructure underneath is in good order. So that's an example of just a repeatable mission. You could run those missions regularly, have the data automatically streamed back to the control center. Also agriculture, huge industry in New Zealand. Just imagine, automated security sweeps, checking key infrastructure along your farm. The drone could do a daily sweep. You could be having your cup of tea, checking all your key sites on your farm, before you even put your boots on. Also, you can put a siren and speaker on the drone. So that's ideal for bird scaring certain times of year when birds are causing real havoc. You can just do automated missions just to keep them off key crops you're trying to protect. Security as well, quite self-explanatory. Cody showed a bit of a security sweep before. So just, very quick deployment, live video feed, ability to send messages through the drone, just a lot quicker response time, eyes all over your site you're trying to protect. And construction surveying. So the drone comes in two different models, which can both be interchanged into the dock. So one is for surveying mapping, and another one has the thermal camera, which is ideal for asset inspection. So the surveying one is ideal for construction site management. You can do a lot more regular sites, also stockpile measurements, quarry sites, huge benefits there just on repeatable missions. So just talking about the hardware in particular, really common question we get asked a lot is, what was the cost? And it's very affordable. It's amazing, what the packaged cost with the box, the drone, the remote control, the battery. So for the mapping drone, which is very similar specs to the Mavic 3 Enterprise, most of you will probably be familiar with, that's 23,500 New Zealand dollars. And for the thermal version, which is very similar specs to the Mavic 3 Thermal you'll be familiar with, 26,500. The main difference between the Mavic 3 Enterprise range and what they call the Matrice 3D range is that it's also IP55 waterproof, so extra benefit there in operating in adverse conditions. So just quickly touch on some other cool features. It's 4G enabled, so as Cody mentioned before, the 5-kilometer inspection down the line, we had to rely on 4G communication there to go that length, because where the dock was positioned, it didn't quite have the legs to take it all the way, so unlocks huge potential 4G capability. Also, you have the ability to dock hop, so you can install multiple docks along a path, and they can just land and recharge and keep flying on their route. So don't have to return back to the original dock to recharge. So it really broadens the areas that you can cover. As well, there's multiple software support. DJI really opening up their API to allow other parties to integrate. So Drone Deploy have a fantastic integration with their software, dock automation. So if you're a Drone Deploy customer, very easy workflow there. You can do your mapping missions through the Drone Deploy app, and once the drone lands back in the dock, automatically into your Drone Deploy software as you're familiar with. And yeah, dust and waterproof IP55, which is the one advantage over the Mavic 3 Enterprise series. So the idea of this webinar is to get everyone in New Zealand dreaming, just realizing that this technology is here, it's been approved, it's super reliable, and what is the next steps to get going? If you want to get going, or you've got think this could work well for your industry, get in touch with us. And the first step would be to consult with our team and just understand your mission objectives, the area you're looking to fly, your data capture, deliverables. And then we would come to your site, we would set up the dock, would set up a couple of automated missions, make sure the data is the quality you're after. We'll also just figure out what power and internet we can get on the site. because that's the key to get the dock going. You need power and internet. A lot of the time on remote sites, we're using Starlink, which is very reliable and has the latency requirements we need to be able to operate it effectively. And then, yeah, once on site, like I said, there'll be a proof of concept, just making sure everything's up and running. So, and then the next thing you need to figure out is how you want to operate the dock. So you can obviously do it from a ROC, you can set up your own ROC, or you can outsource to other companies who specialize in operating ROCs. There's a sister company called Beyond UAV that's about to go live, and they're just going to specialize in ROC flights, which for some companies that will be the most efficient solution, outsourcing all the compliance, the risk on that. But companies who want to scale and run their own ROC, that's a great way to go and huge benefits. But also another way you can operate the dock, which is hugely popular in the States for construction progress tracking, is just flying a visual line of sight. So the visual line of sight, you can fly under the standard 101 rules. You're still getting huge benefits of the automation, the automated data upload, and battery management storage. So there are multiple ways to consider how you would want to operate the dock. But as far as the ultimate goal from the ROC, remote pilot, no human on site, that is possible in New Zealand. We flew before from our ROC, and who really helped us get that privilege across was Hover UAV. So I'll pass you over to Nick now from Hover, based in Christchurch, and he will talk a little bit about the regulations in New Zealand. Yeah, thanks all for joining. Hope it was insightful.
Thanks, Tom, for that. Kia ora, everyone. I'd just like to start by acknowledging the great demo and case study that we've just seen from Orion and Ferntech. It really showcases kind of the opportunities that we've seen with drones, and that's already happening here in New Zealand. So yeah, quick intro on me. I'm Nick from Hover UAV, part of Jackie's team. I'm based in Christchurch, and I'm working closely with companies from around the country and across a range of industries to support them and help them with navigating the regulatory system here for unmanned aircraft, and also helping them to start and advance their drone programs. And today I'm going to walk you through the rules that govern what we do and how they support safe and innovative drone operations in New Zealand. So yeah, in New Zealand, our aviation system is governed by the Civil Aviation Act. This is the piece of legislation that governs all the civil aviation activities in New Zealand, including drones, and sets the framework for safety and security. And then supporting that are the civil aviation rules. So for unmanned aviation, as Tom mentioned briefly earlier, the two key rule parts that apply are Part 101 and Part 102. Part 101 is designed for lower risk operations, while Part 102 is for the more complex ones, and I'll dive into both of these in a bit more detail. So taking Part 101 first, this is the rule that allows lower risk operations to proceed without needing any authorizations or approvals from CAA. It's often the starting point for many operators, whether they're recreational or commercial operators, and it allows basic operations to get up and running straight away. However, there's some key limitations that you have to follow when operating under Part 101. So your aircraft must be less than 25 kgs, you can only fly during the day, and you must always have your aircraft in visual line of sight. For flying over people or property, you need consent. You must keep your drone below 120 meters or 400 feet above the ground. There are additional restrictions around flying in controlled airspace or near aerodromes. So that's kind of just like a high level summary of what sort of what you can get started doing under Part 101. However, when you want to do something that goes beyond what those limitations allow, such as like flying at night or beyond visual line of sight, operating remotely, you'll need to operate under Part 102. So Part 102 is designed for the higher risk or more complex operations. And Part 102 is a performance-based rule, so it offers flexibility as it doesn't contain any prescriptive requirements for an operator to meet. It instead enables operators to assess their set of operational risks or their risk profile, and then they can propose the risk mitigations to apply to the operations. So you do this by providing an operating manual, also known as your exposition. And this details how you identify hazards and mitigate those risks of your operation. Things like all your procedures you use, your maintenance, the structure of your organization, all of that comes into it. And then the CAA will assess your application based on your risk assessment and mitigation plans and how you plan to operate, and decide whether they think you're going to be doing that safely enough, in which case they'll give you your certificate that will allow you to operate with some of these privileges that you might be looking to do. So for operating like BVLOS or setting up a remote operation center, Part 102 is definitely what you need there. So a sort of high level overview of the actual process for going through and getting a Part 102 certification. It starts with preparation. So you need to define your concept of operations, what's known as a ConOps, which outlines what you plan to do, where you'll do it, how you ensure safety. And then this is backed up by the detailed documentation. So the operations manual, the procedures, the risk management documentation. And once your application is ready, you submit it to the CAA, and from there, it might sit in the queue for a little bit, but then it'll be assigned to an inspector who will review everything. They might ask you for additional information or ask you to make some changes to ensure that it sort of complies with what they think needs to be done for it to be done safely. And you also nominate a prime person who's kind of the person at your organization who will be sort of overseeing and taking responsibility for your drone operations. That person will give an interview as well before the final approval is given by the CAA. For more complex Part 102 operations, such as like long-range BVLOS or remote operations with a ROC, like what we saw earlier, there are kind of a couple of extra steps in there that are required, and generally, like something like a safety case will be needed to accompany the exposition to detail in a bit more with a bit more consideration for different risks around how you'll do this safely. So ways we've done it before is we create a safety case under using recognized methods such as SORA, which helps to assess both the ground and the air risk and determine mitigations that can be put in place to operate safely. It's quite a methodical process that we go through. And for example, for a ROC, some of the key questions that would need to be asked and sort of addressed within the safety case include how you're minimizing the ground risk and how you minimize the air risk without having someone on site to monitor those. So you'll be considering things like the communication methods you're using, both with like into the dock from where you are, as well as the dock to the aircraft, and the aircraft and communication redundancies you have in place for something goes wrong. Other things you might be considering are ADSB in, aeronautical radios, cameras, things like stakeholders consultation and site security to help manage the ground risk, and then sort of things like your procedures and aircraft maintenance, other factors that you have to consider, and then demonstrate through your safety case to the CAA kind of how you're managing that operational risk. So that safety case would then be submitted alongside the relevant exposition. The CAA would review that before approving for you to be able to begin those operations. Yeah, so to finish up from me, yeah, for those looking to take the next step into these kind of more advanced operations, my advice is definitely to start preparing early and engage with experts like Tom and his team at Ferntech. You can also come and talk to us at Hover. We've done this before. It is a detailed process and it can take a wee while, but as you've seen today, it is definitely possible and it's already happening in New Zealand. And there's some really cool benefits that both Tom and Peter kind of outlined that can unlock some great efficiencies within your businesses. So yeah, that's it from me. I can jump back to Jackie to run our questions.
Perfect. Thank you so much. That was a great presentation and you all kept on time. So you've made my job really, really easy. And we've still got, 10 minutes of official questions and then I might turn off for more of a general chat after as well. We'll turn off the recording. So I might ask, and these aren't the ones we discussed earlier. I might ask about maintenance. So I might ask Cody and even maybe Peter, sort of, you've been operating now the site down at Orion. What does it look like from a maintenance perspective? Like how often do you need to be involved? Is it something that you need to sort of, go and, maintain every month? Is it 6 months, or you want to talk through that process?
So we look at go to the UAV every month and check it, do open the box, check the aircraft, check the propellers, check all the equipment on site that we need for a SORA. So things like the fire extinguishers there, the repair kits, all those things are done. So it does get looked at once a month, which I think is part of the ROC for that site, or the SORA for that site. I'm pretty sure that's right, Cody. You there?
Am I on mute?
Hey, sorry, Peter, that's correct. Yeah.
So Orion makes sure that happens, and we send a checklist through to Ferntech every month so that we have completed a visual site inspection.
You can unmute.
But Peter, I was just thinking, 200 plus flights and all the props and everything in pretty good nick, eh? Last update I heard from you.
Yeah, it's quite staggering actually. When we popped it open, Dan came down, Dan Morton from Ferntech came down and gave it a full working over, and it was pristine inside. Like it's we're in the country. It's got exposure to every possible environment, from hail, wind, snow, dust, and the inside of that Dock 1 was spotless. Was actually staggering. We've had no vermin, no birds. There's no mice, nothing, which we quite commonly get in our country subs. So we were quite staggered how little maintenance is actually required, and the aircraft itself is in pristine shape. Looks like it just came out of the box, and it's done a lot of flying.
Yeah, perfect. Look, this one might be for Peter. Oh,
Apart
sorry.
from the bird put on the top of the dock that needs to be cleaned.
This one might be for the same people though as well. I noticed in that flight, Cody, that the drone was really quite close to that infrastructure. So, Peter or Cody, have you seen sort of, has it ever hit? Like how do you manage flying so close to get that data?
Yeah, as I mentioned, with the model we've got, we know pretty precisely with that waypoint where the drone's going to be. So we sort of, when you set up the mission, you'll start a bit further away, test it, get a bit closer, just keep nudging it a bit closer. And if we do get too close, the obstacle avoidance sensors kick in that we see on most of the drones. And then it will do a return to home. And it's got a cool thing now. If it does need to go into return to home, it can actually return to home via the path that it got there. So rather than just going straight up, it's sort of like a smart return to home. And then having the RTK on board, the RTK with the model that we've done and the RTK on board, we know precisely, centimeter level accuracy, it's going to be in that position.
Yeah, perfect. Tom, this one's for you, and it's a question from Carla from the Q&A. Sort of, is the M30, I mean, I know for this demonstration you were using Dock 1. Do you want to sort of talk about, I guess, the other drones, or you're saying is that the largest that fit in there? I guess talk about that, they are specific to that box, and what sort of other drones in the Dock 2?
Yeah, correct. So the proof of concept on the Orion site was the Dock 1 with the Matrice 30T drone. That is almost identical to the M30T. You can just buy off the shelf and fly the controller, except it has a special charging port at the bottom. And so then just last year, mid last year, the Dock 2 was released. So that uses, as I covered off in my slides, it's called the Matrice 3D series. So that's very similar specs to the Mavic 3 Enterprise series you will be familiar with. So the difference in those two drones between the M30 and the Matrice 3D is the Matrice 30 has a laser rangefinder on it. Also, one of the huge improvements is the retail price is about 50% cheaper for the Dock 2. So they managed to bring the price down substantially with not sacrificing much of the specs at all. Flight times, all very similar, IP rating, and also the actual Dock 1 was 100 kg, so it's a very difficult unit to transport around, when the Dock 2 is far more light and just two people can carry it to move it around.
Yeah, perfect. And also, you know what, DJI seem to come out with new new products and new docks and all the time. So I'm sure that, you know, moving forward, we'll start to see new products as well. And that's something that, you know, can easily be taken into consideration when developing a safety case, that, you know, you may need to, you know, be prepared sort of, you know, to develop a safety case that might be Doc 1, Doc 2, and so it can also be, I guess, ready for the future as well. We are pushing nearly the time, but I've got one more question for you, Nick. Looking into the future, and I'm not saying this is what Orion or anything need, but you know what? The proof of concept work, the trial's working, they're using it every day, you know, it's a success. What are other things, I guess, do you want to explain what one-to-many might look like? I mean, sometimes it's called swarming, but, you know, do you want to explain what might be next for, you know, these organizations to further streamline their operations?
Yeah, I mean, there's definitely a lot we're sort of starting to see people looking at or starting to look at doing. Yeah, one-to-many is definitely one where you can have one pilot that's controlling many drones. So that might be from the likes of a remote operations center. You have multiple screens up in front of you, and you can have the one pilot who's controlling those drones that are going out and doing your mission without having, you know, a whole team of pilots to work on that. And there's, you know, other things like kind of that long range BB loss we're starting to see more and more of as well, which would allow, sort of being able to go further for your inspections. You're looking at things like power lines and railways and things like that as well. There's definitely a lot that can be done. And that's one of the great things, I guess, with the CA's Part 102 being performance-based rather than risk-based, is you can then start talking to the CAA and proposing kind of what you want to do and work out how you can do it safely. It's not like there's sort of a whole lot of stuff that's just straight up banned. They'll discuss with you and work with you to work out how you can look to do some of these operations safely.
Yeah, perfect. And there was a about the ratios to 1-many, and I can sort of answer that. So, well, look, we're seeing in Australia that you know, there are organisations that have got one pilot up to 50 drones at one time. And we do sort of start to say sort of, you know, start small, and it depends on the software that you have, because it's that human machine interface. So does your software allow for, you know, that you can manage, you know, multiple non-conforming like drones at the one time, and how does that visually see? Can you see all the failures or how it's operating? So a lot of people start, you know, maybe 2 to 4 at one time, and then I would say move to 10, but it will really depend on that software solution that you have and how it interacts and how that remote pilot will manage if there is a failure and what happens to the other aircraft. But it will just continue to change as software gets better as well. And all of those processes, this is just, you know, an approach as well, like, but all the information from these initial trials, so 1-to-1 to, you know, initial BV loss or flying the visual line of sight, you can utilize that data to then present to the CAA or any other regulator to sort of prove that reliability and the safety of that equipment. So as we push now that time, I just firstly, we will stay around after for everyone that has any other questions as well, but I will wrap it up from a video perspective and recording. But I really want to thank, you know what, this, to move emerging aviation and to move to where we need to be, you know, in 3 to 5 to 10 years time, it's a collaboration, not, you know, one organization can do everything. So we're really happy to, you know, partner for this webinar with Ferntech and Orion, and really show that collaboration of what, if you do collaborate, what can be achieved as well. So I'd like to thank Tom and Cody and also your extended team there as well, which I know that they were flying in the Remote Operations Centre. And Peter, I'd really like to, you know, thank you for joining and sharing your end use case. Yep, I can see there was a lot of other utility and power companies online, and I'm sure that they got, you know, really great understanding of the benefits associated with that case study. Thank you to Nick as well. Really appreciate sharing the insights. as always, please reach out to any of us. So, you know, if you do have any questions, please reach out to Tom or myself or Nick or Cody or anyone, and we're more than happy to sort of support you on that journey. There are no dumb questions. We know that we're all in this together. So, you know, reach out early and we can support you through the journey. So thank you very much. All the information is there of the contact details. We are going to stop recording now, but please, we're going to stay around and just have a general chat for a few minutes. So if you've got any other questions, please pop them in as well. Thank you.